on temperature patterns in recent months, and then we'll get stuck into what the long-range forecast that came out yesterday are showing. And then I'll sort of follow on from what Emily, how she was explaining the climate drivers or seasonal influences. I'll give you an update on what they're doing right now and what we expect them to do in the coming months. So first of all, looking back at May, and these are our deciles maps, so they compare this May to all previous Mays, back to the year 1900 for that rainfall map on the left, and back to the year 1910 for the temperature maps in the centre and on the right. So looking at that rainfall map first up, you can see we've got that blue area across the east where they had above average rainfall. But in contrast, we saw that below average rainfall for parts of the west and southwest. And then there's also plenty of areas of white on that map where people had pretty typical May rainfall. The map in the centre, maximum temperatures, is a bit more extreme. So we've got that sort of dark orange shading across most of the state. So most of the state had its highest on record maximum temperatures for May. And when we take the area average for the whole state, it was Tasmania's warmest May on record for maximum temperatures. Minimum temperatures, again, warmer than average, but not quite as extreme. But it was Tasmania's seventh warmest May for minimum temperatures.
Yeah, I think, and we saw that with pasture growth as well, where that mild winter compared to the usual what we had, so it was progressing that pasture growth from some of that. We had a late autumn break, but I think those late rains were still useful because of that. I think that shows that those warmer May days really started to elongate it out. So yeah, it shows.
Yeah. Now looking back at autumn overall, you can see a lot of the state did have below average rainfall, mostly parts of the west and the north. Although for a lot of the east and sort of the far northwest, it was more typical for autumn overall. Maximum temperatures mostly sort of very much above average, but little area of highest on record in the south. And when we take the area average for Tasmania overall, it was the second warmest autumn on record for maximum temperatures. And minimum temperatures, a similar pattern, very much above average for most parts, with an area of highest on record for parts of the south, southwest. And for Tasmania overall, it's ninth warmest autumn on record. Now, we'll just stick on rainfall for a moment, and this is looking at sort of the first 5 months of the year, so January to the end of May. So there's a deciles map there on the left. So you can see most parts of the state had below average rainfall for January to May, although there were some patches of the east where it was close to average. But then you've got this sort of area of the north, northeast, but also the southwest where rainfall was very much below average. Now, the Bureau puts out a drought statement every month, and we use a different set of maps for that product. We call them rainfall deficiencies maps, and they more sort of clearly highlight areas that have had particularly low rainfall. And that's that map on the right there. So for that serious deficiency, that light pink category, that's rainfall that's in the lowest 10% of the climatological range or the historic range for January to May. And that medium red or pink shaded area, that severe deficiency category, that's in the lowest 5% of records for January to May. So there is parts of the northeast and southwest that have had a very dry start to this year. Now, looking at water storages, so the map on the left, each of the circles there is a water storage or a dam, and the size of the circle corresponds to the capacity of the dam, and the colour corresponds to how full the storage is. And it's a bit hard to read because the circles are all sort of stacked on top of each other. You can see that there's sort of a large brown circle sort of in the central north. That's the Great Lakes. But otherwise, most of the other big storages in Tasmania are getting close to capacity. They're in that sort of blue or dark blue shaded colour. It's quite a different story to what we're seeing for parts of the mainland's southeast. You can see, parts of sort of southern New South Wales, northeastern Victoria, some of the big storages there, less than half full. And then across Victoria, it's quite a mixed bag. We've still got some of those blue and even a green circle where storages are full, but there's a lot of sort of light brown and darker brown circles as well. Now on the right-hand side, just another diagram illustrating the capital city water storage, so Hobart's water storage, sitting at a very healthy, close to 96% full, and about the same level it was at this time last year. Now, before I show you the current long-range forecast, I just thought I'd add a little bit more detail about what is this, what is the Bureau's climate model? Well, it's called Access S. That's not very important. But what is important is that it's a dynamical model. So it's taking observations from below the subsurface and the surface of the oceans, but also from the surface of the land areas and up through the atmosphere. And it's putting all of those initial conditions into a big sort of simulator, and then we're moving it forward in time. Now, in the past, in the olden days, we just used a statistical model, which really just looked at the relationship between the Indian Ocean dipole and the El Nino Southern Oscillation and rainfall across Australia. But this new dynamical model takes into account sort of all of the influences, not just those two. Now, the very early versions of these dynamical models were pretty coarse. There's a box there on the left-hand side. So the original dynamical model called POEMA, it had a resolution of 250 kilometres. That was its grid size. So it couldn't actually resolve Tasmania in the model. It was just treated as part of the ocean. The current model we're using these days has a grid size of 60 kilometres over the land areas and a 25-kilometre grid over the oceans. So it can resolve Tasmania, it can resolve the Great Dividing Range, and it can also resolve sort of the currents we see in the oceans. Now, it's not, when we call it a model, it's not just this one model or this one forecast that's being run. We call it a lagged ensemble model. And so we're running that forecast 99 times. We're doing it 33 times on day one, then 33 times on day two, then 33 times on day three, then bringing all those 99 individual forecasts together and finding the average of those. And that sort of gives us our probabilities, but it also tells us something about that probability distribution. So top right corner, just to give you an example, that's the forecast for the sea surface temperatures in this region of the tropical Pacific that climatologists look at because it gives them an indicator for El Nino or La Nina. So you can see that green line. Well, that's the average of all those 99 members. So that's, the forecast that we talk about. But you can see that the light grey lines in the background, that's all the individual members. That's the 99 individual members making up that forecast average. And you can see in that particular plot, you can see, we're expecting further warming in that region, and all of the members, all 99 members agree that it's going to be sort of at El Nino levels during winter. Now, just below that, I've got another example. This time it's the rainfall forecast for Hobart for the coming 5 months. And that dashed black line is the average of all the individual members. So you can see that for June and July, that dashed black line, it's kind of nested within that white band in the background. So we're looking at a forecast for rainfall that's pretty close to your average, pretty close to your median. But the box and whisker plots, those green box and sort of lines, tell you about the spread in the ensemble. And what they're showing is that the average of all the 99 members is a value that's pretty close to average rainfall for June and July. But you've got some members out of those 99 that are actually going for a really dry outcome, and some members that are going for a really wet outcome. And it's just that the average of those happens to collapse to a value that's pretty close to sort of average rainfall. So now the actual forecast. First of all, this is for the 1 month. So this is for June. We'll start with that rainfall forecast there on the left. And you can see for parts of northern New South Wales, eastern New South Wales and Queensland, we've got a bit of a dry signal there. We've got those brown colours. For Victoria, there's a bit of a wet signal for parts of the west extending into the agricultural areas or parts of the agricultural areas of South Australia. And for Tasmania, we've got something different again. We've got, a sort of light green shading in parts of the west, and we've got that light brown shading for that area of the east. And then in between those two, it's a fairly white looking map. So there's not a strong signal in that rainfall forecast for Tasmania. There's a weak wet signal for parts of the west, and there's a weak dry signal for parts of the east. But for a lot of the state, there's not a strong push either way. And for those areas... Sorry,
can you remind us what that long range forecast, how far out that is?
Yeah, great question. The one we're looking at on this slide, this is just for June. So for the 1 month of June. And so for a lot of Tasmania there's not a sort of a strong signal. But for those areas that are sort of white or grey, it's not a forecast for near average rainfall. It's a forecast with a fair amount of uncertainty, and you should expect or should be planning for anything from below average to near average to above average. And when you look at sort of the wet signal in the west, it's in that 60 to 65% chance category. So about 2/3 of those 99 models were going for wet and 1/3 of them were going for dry. So, it's not even a sort of a guaranteed that you're going to have, a wet June for parts of the west, but that's the tendency. That's, the way sort of the model is inclined. Now, if you look at the maximum temperature map in the center, you can see it's got a lot more signal in it. It's showing high chances of having warmer than usual maximum temperatures right across southeastern Australia. And for the minimum temperature map on the right, you can see again pretty high chances of having warmer than usual minimum temperatures across Tasmania and Victoria, most of South Australia, with those chances reducing further north. So there's parts of Queensland where it's close to a 50-50 chance of warmer or cooler than usual minimums. Now, flicking ahead to July, and you can see that that rainfall map has shifted. It's changed a bit. For Tasmania, we've got a bit more probability, a bit more chance of seeing below average rainfall for parts of the northeast now. But for a lot of the rest of the state, again, it's a pretty neutral forecast. It could really go either way. And so you shouldn't be planning for near average rainfall. You should be planning for a pretty wide range of outcomes. But for the northeast, you might be thinking my chances are it's going to be drier than usual during July. The temperature maps, again, high chances of warmer than usual maximum and minimum temperatures across Tasmania for July. Now we've got our first of our 3-month forecasts. So this is for winter overall, June through to August. And you can see we've got a bit more signal there across parts of the mainland southeast, but also for Tasmania. You can see we've got a broader area with some higher chances in the east, likely to see below average rainfall. But again, for the rest of the state, we're not getting a lot of guidance here. The forecast isn't telling us sort of much. So we should be, planning for just about sort of any result. But for parts of the east, you'd probably think, well, chances are it could be drier than usual. Again, temperature forecast just showing us that we're likely to have warmer than usual maximum and minimum temperatures.
So, Jonathan, can I just clarify that the term using? So when things are sitting around that 50%, so that white area that you see, so that 50% chance, you're not saying that we're expecting average, you're saying we can expect a broader range of outcomes.
That's right. Yeah.
Okay.
You think back to that slide that Emily showed before. If you actually go onto the Climate Outlook's page and you search up your location or click on the map, you'll get that pop-up box, which actually shows you the probability distribution. It's into 5 categories. So some of these areas of white, not all their probabilities, not all the chance is stacked in that middle quintile range, in that middle range. What you'll find is for a lot of places that are sort of white on the map, there's roughly even chances of being in that driest 20% as there is to be in the middle 20%, as there is to be in the top 20%.
Okay.
So it could really go either way. Sometimes if you click on an area of white on the map, you will find that there is a bit of a bulge in the center that, you are likely to sort of get near average rainfall. But for most of the time, when you're seeing white on those maps, what it means is you've probably got equal chances of having below average, near average, or above average.
Yeah, great.
But those temperature maps are looking, a lot more emphatic, showing greater than 80% chance of having warmer than usual maximum and minimum temperatures for most of southeastern Australia, but for all of Tasmania. And for the official public forecast, we can push that out 1 month further. So now we're looking at July to September overall. And we've still got that dry signal for parts of eastern, northeastern Tasmania and the Bass Strait Islands. But you can see for parts of the west and south and even the centre, there's not a strong push either way. Still got that pretty strong dry signal for parts of Victoria and the agricultural areas of South Australia and parts of southern New South Wales on that map there as well. And you can see again for those temperature maps, just looking very red. So high chances of warmer than usual maximum and minimum temperatures. Now, so I was sort of saying before that the long range forecast, they don't have the same accuracy or the same skill as we're used to in our 7-day weather forecast. But to test the forecast, to test the model, to see how well it performs, we could wait until we've got 20, 30, 40 years of forecast to compare them against what happens. But that's, we don't have sort of time for that. We don't have, we want to start using the forecast now and be able to say something about whether or not it's going to be accurate or whether or not we can be confident. So what we do is we grab a whole lot of years from the past, the years from 1981 to 2018, and test the model on those, because we know what the results were. We can go back and see, what happened in this particular month or particular season. And then we can score the model. And that's what we're looking at here, is we're looking at these past accuracy maps for that hindcast period. So on the top row, we've got our 1 month maps. So top left is showing you the past accuracy for the June rainfall forecast issued at the end of May. And what it's showing is that for Tasmania, you've got moderate to high skill or moderate to high past accuracy. But you'll see, when we talk about moderate, we're talking about in that 55 to 65% accuracy range. So that's probably a lot lower than what some people would consider, moderate accuracy. And for high accuracy, it's anything sort of better than 65%. So there's still a lot of room in there to have a miss, even when we are talking about, moderate or high accuracy. But you'll also see there's some parts on the map there, parts of sort of Northern Territory or Northern WA, where the accuracy really drops off, and the forecast, at least for the hindcast period, was no better than a coin toss. Now, top right is the same as the past accuracy outlook for the July forecast issued at the end of May. And generally what you'll see is that the forecast or the past accuracy for that second month tends to be lower than the past accuracy for the first month. So we tend to do a better job, or we've got more predictability at saying what's going to happen in the coming month than we do in the month following that, typically. And then below that, past accuracy maps, but this time for those 3-month outlooks. Sorry, I think I've mixed them up. So on the bottom right, that's looking at winter, so June to August. And sorry, bottom left is July to September, that's season 2. And typically what we see is we get a bit more skill or a bit better past accuracy in those 3-month outlooks than we do for that single month 2. So the way the accuracy sort of aggregates over time is when we're doing those 3-month forecasts, we're more likely to get some of that seasonal signal from those seasonal drivers or influences coming through than we are compared to the weather noise. For those 1-month forecasts, there's still a fair bit of risk that you're going to get a one weather event or a bit of weather noise coming in and sort of muting your climate signal. So the month 1 typically does better than month 2, and the seasonal forecasts generally do better than the monthly ones. Okay, now what are our climate drivers up to right now? So Emily did a good job of describing what El Nino and a positive IOD are, but now I was just going to show you sort of forecasts for both those phenomena and what we think they're going to be doing over the coming months. So top right, forecasts for the sea surface temperatures in the tropical Pacific Ocean, and each of those coloured lines is one of the forecasts from one of the international models. So we've got the Bureau's model in there, but we've also got models from the Canadian system, the American system, the UK, the Japanese, the European model, putting them all in there. And what you can see is there's pretty good agreement between the models. Those lines are pretty tightly bunched together. And what they're all showing is that we're likely to see further warming out in the central equatorial Pacific up to levels that are consistent with El Nino during winter. Great. But that's sort of only half the story. That's sort of telling us what's happening in the oceans. We're likely to have a pattern that's consistent with El Nino. But before we can declare an event, what we really need to see is some coupling between the atmosphere above the ocean and what's happening at the sea surface. And so this forecast doesn't show us that. This forecast is really just showing us what that sea surface temperature pattern is going to be looking like. And it's going to be looking like El Nino at some stage during winter. Now below that, Similar forecast, but this time for the pattern that's happening in the tropical Indian Ocean. And you can see, and again, each of those colourful lines is a forecast from one of the international agencies, but you can see we've got more spread between those colourful lines now. There's more divergence between the forecasts. So there's less certainty in what's going to happen. But you can still make some comments about it. You can still say, you know, standing back overall, mostly they have a similar trend. They're showing that that Indian Ocean Dipole Index is likely to keep rising. And the majority of the models show that it's going to sort of reach a value that's consistent for positive Indian Ocean Dipole event, you know, perhaps sometime during winter as well. So that's showing us that, you know, likely to have an El Nino form, and it's possible that a positive IOD will occur as well. And as Emily was showing us before, both those drivers tend to push us towards below average rainfall.
Could I just interact here, Jonathan, just in terms of, I think it was 2023, where I think there was a fair bit of media attention in terms of the Bureau not declaring an El Nino or a La Nina event. It was a La Nina event, I think, that the American agency, meteorological agency, had declared a La Nina for themselves, but Australia hadn't, and we sort of lagged. And everyone, you know, it was likely, but it's because of the different sort of parameters that we set, because Australia's models are set differently. Are you able to just quickly summarise that?
That's right. The different agencies do have slightly different criteria for assessing what is an El Nino, or what, you know, what's close but doesn't quite make it. I'll show on the coming slides that the impacts from El Nino, the timing is slightly different as well. So for some of these agencies, the impacts from an El Nino are happening earlier, and so that's part of their motivation to perhaps, you know, make an announcement earlier than the Bureau would. But yeah, the other reasons just can come down to just small differences in the criteria that we use. For the Bureau, we're pretty cautious, and generally we want to start to see a response from the atmosphere before we declare an El Nino is underway. We could have that warm sea surface temperature pattern, but if the atmosphere doesn't play ball, then we're not going to get coupling, and we're probably not going to see any of the widespread impacts from the event. And now, getting back to the slide that I've got on the screen at the moment, this is showing you what's happened in the past when we've had El Nino during spring. That's the map on the left. And on the right, what's happened when we've had that combined El Nino plus a positive Indian Ocean dipole. And you can sort of see when we've got both those drivers in play, generally it's a broader and in some areas more intense reduction in rainfall that we've seen on average. So yeah, having those two combined can sometimes make conditions worse, or that's what we've seen in the past. And now this isn't the Bureau's map, and it's got a few years on it now, but this is really just illustrating that it's not just Australia or parts of Australia that are impacted by El Nino. We see changes to rainfall patterns, you know, right across the globe. You know, but the big one, I guess, is what's actually happening along the sort of the equatorial Pacific. You know, during El Nino, we get a lot of rain, or a lot of above average rain falling out there over the oceans, where it's not really helping anybody. And we tend to get suppressed rainfall across Australia, but also up through Indonesia as well. You can also see, typically we see below average rainfall for northern parts of South America and for parts of Africa as well. But we get, you know, the opposite influence for parts of North America. You can see there, you know, for parts of North America, there we'll actually see above average rainfall, but sometimes for parts of the Southwest, that can occur much earlier in the year. And so that's one of the motivations, I think, why we see the North American agencies sort of declaring ENSO phase sooner than the Bureau often does, because some of those impacts can occur earlier for them as well.
Now, this is where I want to kind of butt in here, Jonathan. Sorry, just for the interest of time. I know that I was a bit blasé before, but yeah, if we could, look at starting to summarise.
No worries.
Tassie, just so people pays to be, so we can
Very quickly, I'll just mention the southern annular mode. So the SAM forecast the SAM phenomena that Emily was showing us before definitely can influence rainfall and temperature patterns for parts of Australia, including parts of Tasmania. But it's not as predictable as El Nino Southern Oscillation or the Indian Ocean Dipole. So the plot top left there, that's the daily forecast for SAM. So that green line is the average of all those individual members. And all that big mess in the background, all those light grey lines, that's your 99 individual forecasts. And the green is the average of those. And you can see that after a few days, after a week or so, that really just blows up. It gets really chaotic, and you get sort of every result from, quite a strong negative index to quite a strong positive index. So SAM can be useful when to explain, what we have seen, but it's less helpful for making those sort of monthly or seasonal forecasts. Now, along with those natural drivers, the El Nino Southern Oscillation, Indian Ocean Dipole, Southern Annular Mode, our weather and climate is being affected by climate change. This is a time series of winter mean temperature anomaly going all the way back to 1910. So each of these bars is a winter for Tasmania. And you can see there's a pretty clear warming trend in this time series from 1950 onwards. So not every winter is warmer than the previous one, but you can see the dice are they're loaded towards giving us a warm result for winter. Likewise, there is a change, or there's changes happening to our cool season rainfall patterns associated with climate change as well. Now, for Tasmania, it gets a bit complicated. If you look at that time series on the left, it's not really obvious there's a trend in it. There's sort of an equal number of sort of above average and below average winters. I guess what you would take away from that, though, is you can see just how variable rainfall is from year to year. It can really change a lot more than what we saw in that temperature time series. But the map on the right is what I want to show you. And that's illustrating the trend in cool season rainfall across parts of southern Australia. It's comparing the cool season, April to October rainfall for roughly the recent 30 years to all years back to 1900. And what it's showing is that for parts of the mainland south, this recent 30 years has been very much below average to lowest on record. But for Tasmania, what it's showing is that what we've seen in recent decades for the cool season, we've seen a drying trend for parts of the north, but at the same time, we've seen parts of the west actually getting wetter than usual. And so you'll hear more about El Nino and potentially about a positive Indian Ocean Dipole through the media for this coming season. But I want you to remember that there are other reasons why we could be getting a warmer and drier outlook as well, just based on the trend we've seen over the last 30 years. So to summarise, there's a weak wet signal for parts of Tasmania's west and south, contrasting with a weak dry signal for parts of the east during June. But for a lot of the state, there's not a strong signal, and you should be preparing for everything from sort of below average, near average to above average. For winter overall, there's a bit more signal and a bit more confidence for the east and northeast that we're likely to see below average rainfall there. But again, not getting a lot of guidance for the rest of the state. But what we do have more confidence and more signal in is those temperature forecasts. And we're likely to see warmer than average temperatures across Tasmania for winter overall. Happy to take questions to my email address at any time too. Thanks very much, Ben.
Right. Thanks, John.